Hi everyone, here I am going to discuss about rules to write electronic configuration. Dear students, while writing electronic configuration of elements, we must have to follow some different types of rules. That is above principle, Paulis exclusion principle, hoons rule of maximum multiplicity, stability rule, n plus L rule, etc. So let's be discuss here one by one. In that, the first one is the up bow principle. What is? The first one is the up bow principle. So just you have to focus on your pronunciation. What is your pronunciation now? Up bow principle. Okay. So up bow means that is a growing. Okay. Means actually it is a name of scientist. But here according to the pronunciation, up bow means it is goes to the increasing. Here it states that what is the statement of up bow principle? That is in the ground state of an atom, in the ground state of an atom, the electrons are enter into the available orbitals according to their increasing energy level diagram. Means first here you have to substitute the electron in different types of orbitals according to their energy level diagram. What is the first one? Up bow principle means you have to substitute electrons with respect to the orbitals according to their energy level diagram. Means what is that energy level diagram? How to remember this energy level diagram? Because this one energy level diagram, it helps more to write the any element electronic configuration. So let's start to write here. That is energy level diagram. Dear students, here just I will provide one very easy tricks to solve any type of electronic configuration with respect to the element. Okay. So here first you have to focus what to write here and then how to write here. Okay. Here first one you can write number 1 time, then number 2 time, after this one number 3 time, after that number 4 time, and then next one is 5 it is equivalent to the fourth one, after that one 6 it is equal to the third one, and now 7th it is equal to the second one. Okay, are you getting this one? How to write this one? First, number 1 you can write 1 time, number 2 write 2 times, number 3 write 3 times, number 4 you can write 4 times, number 5 you can write equivalent to the fourth one, number 6 it is equivalent to the third one, number 7 it is equivalent to the second one. Okay, so now here we are having only the 4 types of orbitals. Is it right? What are those? Yes, S, P, D and F type of orbitals. And dear students, now you are observe here, this is the first row and this is the second, it is the first column, it is second column, it is third column and this one is an fourth column. Is it right? Okay, so for the first column you can write here yes, 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 yes and yes. For the second column you can write here P, 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 P. And for the third column D, D, D and D. For the fourth column you can write here F and F. So now 90% energy level diagram is over now. Just you can make a arrow mark like this one, and now according to this arrow mark you can substitute the electrons in the different types of orbitals. So just it is energy level diagram is over now. Is it easy now? Okay. Dear students, according to this energy level diagram, means in the S orbital, we can substitute the maximum number of electrons 2. In the P orbital, we can substitute the maximum number of electron 3. And in the D, we can substitute maximum number of electron 10. And in the F, that is, we can substitute maximum number of electrons, that is 14. Okay. And now, you may count the total number of electrons in this diagram. That is the S2 and then P6 and then D10 and this is F14. Means 1, 2, 3, 4, 5, 6, 7. Means each S carries, it is a 2 electrons, means 7 into 2, that is the 14 electron. 1, 2, 3, 4, 5, 6. Each p orbital it carries the 6 electron, and 6 into 6 that is the 36. And now 1, 2, 3, 4. Each d orbital it carries the 10. 10 into 4 is, that is a 40. And then each f orbital it carries a 14 electron. 14 into 2, that is the 28. And now you can count all these number of electrons. It will become, that is a 118. 118 means in the periodic table we are having total number of elements are the 118. Is it right now? Okay. So it is just tricks to write or tricks to draw energy level diagram. Energy level diagram. Okay. So now, for example, now I want to write here the electronic configuration for the carbon atom. While writing the electronic configuration, we must have to know about the atomic number. Atomic number. Dear students, try to remember at least from 1 to 40. From 1 to 40 element with its atomic number. Okay, here carbon, its atomic number is 6. Then electronic configuration according to this energy level diagram. Here 1s, you can write here 1s. What is the maximum number of electron in the s orbital? Yes, you can write here 1s2. After this one, the arrow mark it is goes on 2s. So after this one, 2s2. Okay. So now here atomic number is 6, but here we got only the 4 electrons. And now we have to write here another 2 electrons. After this one, we can move to the 2p. And now here the maximum capacity of the p orbital is 6, but I want only the 2. So now here the electronic configuration of the carbon is the 1s2, 2s2, 2p2. Okay. So for example, hydrogen, its atomic number is 1. Its atomic number is 1. So now you can write here 1s1. So likewise, you have to substitute the electrons in the different types of orbitals according to their energy level diagram. And now let's move to the second one, that is Hoons rule of maximum multiplicity or Hoons rule. Here the statement of Hoons rule is the pilling up of electrons in the same set of orbitals. It cannot start to pair until all the electrons are singly occupied in each. Means, dear students, I am considering here the p orbital. Okay. Same set of orbitals means it is p, it containing the 3 types of orientation. Px, py, pz. Means it is a same set of orbitals. Here you have to fill the electrons first singly in all these different types of orbitals. In all these different types of orbitals means px, py, pz. First you have to fill single electrons. Then after completion of all these orbitals with a single electron, you can start to pair. Means here, for example, P4 is there. Some of you may write 1, 2 and then 3, 4. Some students may write like this one, 1, 2, 3, 4. Okay. So now this is the wrong way and this is the right way. This is the wrong way, this is the right way. Because first you have to substitute in each orbital single electron. After completion of all these electrons with a single electrons, then again you can start to pair. For example, P5 means you may write the electronic configuration like this one. 1, 2, 3, 4, 5. And next one, for example, d orbital. Okay, so now it is the d6 orbital. How could you represent d6 electronic configuration now? Okay, so 1, 2, 3, 4, 5 and now later it is 6. Okay, means here filling up of electrons in the same set of orbitals, it cannot start to pair until all these electrons are singly occupied. So this is about the Hoons rule. And third one is the extra stability rule. Dear student, the stability of any element, the stability of any atom, we can provide it by using two concepts. One is the exactly half-filled orbital. One is the exactly half-filled orbital. Another one is exactly fully filled orbital. Exactly fully filled orbitals. Means here, according to the extra stability rule, the stability of a given atom or given element, it is depending upon the two concepts. One is the orbital is exactly fully filled. Another one is the orbital, it may be exactly completely filled. So dear students, for example, P is the total number of electrons 6. Exactly half filled means that is the 3, P3. And then D, total number of electron in the D, that is D10. Half means that is exactly D5. Okay, exactly that is D5. For example, chromium. For example, chromium. What is the atomic number of chromium? Yes, atomic number of chromium is the 24 and its electronic configuration is argon 3d5 4s1. 3d5 4s1. Actually, its electronic configuration is 3d4 4s2. Okay, but it is not possible to write like this one because this chromium atom, here the d orbital, it receives one electron from the s subshell and it tries to attain the stability. Means here it is in the state of 3d4. And now here it tries to attain the stability means it is trying to attain the exactly half filled. Exactly half filled means that is the D5. Here now D4 is there. So that's why it receives one electron from this s orbital. Then it will become argon 3d5 4s1. 3d5 4s1. Now it is in a stable state. And next you may take an example, that is a Copper, its atomic number is the 29 and now its electronic configuration is argon 3d10 4s1. 3d10 4s1 instead of 3d9 4s2. Instead of 3d9 4s2. Why? Here, because that is it receives one electron from this s subshell and it tries to attain the stability. So that's why it receives one electron from the s subshell. Then it will become 3d10. 3d10 means it is exactly fully filled orbitals. Exactly fully filled orbitals means it represents the stable. Okay, so this is about the extra stability rule. And next rule is the Paulis exclusion principle. Paulis exclusion principle. Dear students, here just you have to very focus on this rule, that is Pauli's exclusion principle. Here no two electrons in an atom can have all the four sets of quantum numbers same. No two electrons in an atom can have all the four sets of quantum numbers same. So means here you may consider that is, for example, here 1s2 means in the orbital it containing the two electrons. Okay, it containing the two electrons. And now here we already completed about the quantum numbers concept. Okay, so quantum numbers are the four different types of quantum numbers. So now here we have to write down for each electron. This is one electron and now this is another one electron. I am writing here the four quantum number. One is the principal quantum number, another one is the azimuthal quantum number, another one is the magnetic quantum number, and then last one is the spin quantum number. Okay. So now here first one is principal quantum number. Principal quantum number means it is represented by the symbol small n. Its value is starts from n. Okay, its value is starts from n, means its symbol is n. Okay, so now here n is equal to 1s2 means n is equal to how much? 1. Okay, so for these electrons also n is equal to 1. And then L means that is a azimuthal quantum number. It is part of the subshell. Okay, it is part of the shell. So now here inside the 1, what is there? That is 0, and then here also 0. Okay, and now M, that is magnetic moment. Magnetic moment is that is a 0, comma plus L, comma minus L. Okay, here L means it is a 0. So now automatically M value is also 0. M value is also 0. And then yes, It is the upward spin. It is the upward spin. So therefore we can write here plus half. And it is downward spin. So therefore we can write here minus half. It is upward spin plus half. It is downward spin minus half. Means observe here, dear students. Here all these three quantum numbers are same. All these three quantum numbers are same. But this fourth one is the different. Fourth one is the different. Means in any case, because here depending upon the spins of the electron, one spin is the upward, another spin is the downward. Means one is the clockwise, another one is anti-clockwise. So now here upward electron it containing the plus half, downward electron it containing the minus half. So therefore here no two electrons in an atom can have all the four sets of quantum numbers same. Okay, here next one is last rule, that is n plus l rule. N plus L rule. Dear students, this N plus L rule, here we have to use this rule to predict the energies of the different types of orbitals. Means here, energy of an electron, it is depending upon only, that is N plus L value. Energy of an orbital, it is depending upon the N plus L value. And now if two orbitals contain same N plus L value, or here just you may write here the energy of an electron, it is depending upon the N plus L value. Okay, and now N plus L value means N is in principal quantum number, L is an azimuthal quantum number. Is it right? N is in principal quantum number, L is an azimuthal quantum number. Here we can predict the energy of orbital in two fashion. So first fashion is it is depending upon the N plus L value. If here two types of orbitals, it containing greater N plus L value, it shows the greater energy. Just you have to compare here. For example, 3s and then 4p. 3s and 4p orbitals are there. Okay, so 3s and 4p orbitals are there. Let's check here which is the greater energy. According to N plus L rule. So now here I am writing N and then here I am writing L value. N value is the 3. N value is the 3. Here N value is the 4. N value is the 4. And then what about the L value? Because here you can predict the L value depending on this type of orbital. Okay. So we already discussed in our previous class, L value it starts from 0, 1, 2, 3 likewise. If it is 0, S, 1, P, D and F. So now what is here? S. S means for which number? That is a 0 number. L is equal to 0. And now here 4P. 4P means what is a P value? P value is only the 1. Okay, P value is 1. N plus L. 3 plus 0 is 3. 4 plus 1 is 5. 4 plus 1 is 5. And now, which is containing the highest energy? Yes, obviously that is the 4p. Which is containing highest energy? Obviously that is the 4p. Because it containing the highest N plus L value. If dear students, if here two orbitals it containing N plus L value same. Means both the types of orbitals or both the types of here the numericals it containing same N plus L value. At that time we have to predict or you may give the energy of that one depending upon only N value. So now let us consider here some examples. I'm writing here for example it is 3s and now 3p, 3d, 4s, 4p and then 4d, 5s likewise. Okay, so here out of this one which is containing the highest energy, likewise your questions. Okay, so you may write here plus N value, L value, N plus L value. Here N value is the 3, N value is 3, N value is 3, N value is 4 and 4, 4, 5. L value, S means that is a 0, P means 1, D means 2 and then again S means that is a 0, P means 1, D means 2 and then S means again 1. Okay, sorry, S means again it is a 0. So N plus L, 3 plus 0 is 3, 3 plus 1, 4, 3 plus 2, 5, 4 plus 0 is 4, 4 plus 1 is 5, 4 plus 2 is 6, 5 plus 0 is 5. And yes students, just you can observe here, out of these 3p and 4s, which is the highest value? highest energy. Out of these two, 3p and 4s, which is the highest energy value? Which is the highest energy values? Okay, so you can solve here n plus L value. N plus L value for the 3p. N plus L value for the 3p is 4. N plus L value for the 4s is also 4. 4s is also 4. So now here n plus L value for these both, it is same. N plus L value is same. Then how could you differentiate the energy for this one? Okay, or how could you predict the energy for this type? Just you can use here n value. Which is the greater n value, that will show the highest energy. So now here n is equal to 3, n is equal to 4. So now automatically it shows the highest energy. Are you getting this one? Automatically it shows the highest energy. So likewise also here 4p and 5s. 4p and 5s. Out of these two, which is containing the highest energy? Because here n plus L value is also 5. Here also n plus L value is also 5. And this is the 4p and this is the 5s. 4p and 5s. Depending upon the n value, it shows the highest n value. So therefore, it shows the highest energies. So this is about the n plus L rule. Okay. So these all are the rules to write electronic configuration. First one, above principle. You have to substitute the electrons in different types of orbitals according to their increasing energy level diagram. Hoons rule means you can first substitute a single electron, then after that one you can start to pair. Okay. Here, next one is the extra stability rule. Extra stability rule means here we can follow the two types. One is exactly half filled, another one is completely filled. And next one is Paulis exclusion principle. No two electrons can have all the four sets of quantum numbers same. And then n plus L rule, this rule it is used to predict the energies of the different types of orbitals. Okay. And I hope all of you understood this one.